Hi, this is JD, and in this lecture we're going to look at rational expressions from the last lecture, continue on looking at that, and then also rational equations. So here's an overview. We're going to first continue with rational expressions. We're going to look at adding and subtracting, and then we're going to look at rational equations. And you're going to find that rational equations are slightly easier. So these are only like the main two topics within this unit, but the adding and subtracting of rational expressions can be difficult. So here are the steps. First step is you want to factor the denominators completely. Step 2 is you want to find the LCD. Step 3 is you want to use equivalent fractions to make a common denominator. And then you want to add or subtract the numerators and then simplify if possible. Now you might realize, hey, those steps sound like adding and subtracting fractions. So let's do that. So we have 7 over 9 minus 5 over 6. There we are. It's 9. Where's 6 at? There's 6. It's odd. Alright, so we're going to find the LCD. First we want to find the GCF. The GCF of 9 and 6 is 3. Then if you recall doing this, what times 3 will give you 9? 3. What times 3 will give you 6? To multiply all those together, 3 times 3 times 2, which is 9 times 2, which is 18. That would be the LCD. Now we're going to find a common denominator. Well, we found the common denominator 18. Now we're going to use equivalent fractions. So in order to get 18 for 6, I need to multiply it by 3. So I multiply the top and the bottom by 3. Then here I want 18. What times 9 will give me 18? 2. Kind of look over here, it's that leftover number. So multiply the top and the bottom by 2, you get 14 over 18 minus 15 over 18. Subtract 14 minus 15 is negative 1, and you would keep the denominator the same, which would be 18. So now let's do adding and subtracting of rational expressions, and we're just going to do one problem for each of these sections. And if there's more examples you want me to do, I can always do those during the conferences. So I'm going to look at x squared minus 1 and x squared plus 2x minus 3. I want to find the GCF. X squared minus 1 in factored form is x minus 1, x plus 1. And then here it would be x plus 3, x minus 1. So they have an x minus 1 in common. The other factor that I mentioned is x plus 1. And then over here I mentioned x plus 3. So multiply these together, and you don't have to simplify them here. You can just put it as those multiplied together, and that would be your LCD. So this is what it looks like in factored form. So whatever's missing is what you want to multiply the top and the bottom by. So here, this fraction is missing the x plus 3. So you would multiply the top and the bottom by x plus 3. This one's missing x plus 1, so you would multiply the top and the bottom by x plus 1. Now, if I multiply these, so that would be distributing the x, that's x times x is x squared plus, and then x times 3 is 3x. So that'd be x squared plus 3x. Now for this one, you have minus 3 or negative 3. You would distribute the negative 3 both to the x and to the 1. So that would be negative 3x times the negative 3 times 1 gives you negative 3. Now combine like terms. The 3x minus 3x cancels, and that leaves you with x squared minus 3. And that's it for that one. Now notice here I put LCD. I just like doing that so I don't have to keep on writing the LCD every single time. Because if you're able to factor x squared minus 3, you would want to factor it, and then you might have more things canceling. So now let's go to the next topic, which is how to solve a rational equation. So first, your goal is to solve for x or x's. Step 1 is to multiply both sides by the LCD. Easily seen when you factor those denominators. Simplify both sides. Now, once you simplify both sides, you'll see if it's whether if it's linear, quadratic, or some higher degree. If it's linear, it would just be a regular x, and then you would just solve for x. If it's a quadratic or higher degree because of the section that we're in, then you would solve by factoring. And then you want to verify the solution. And the reason for that is kind of what we saw last unit, that the domain of a rational expression or equation is restricted. So whenever the domain is restricted, you have to check. So looking at this one, the denominators are pretty much factored. So I can see that my LCD is 3 parentheses x minus 2. Rewrote it. Multiply each of those by 3 parentheses x minus 2. That's 1 times 3 parentheses x minus 2, 2 times 3 parentheses x minus 2, and then 2 times 3 parentheses x minus 2. Notice that the x minus 2 cancels out, leaving you with 3. The x minus 2 cancels out for that second one, leaving you with 2 times 3. The 3's cancel, so that's because that minus sign, so it'd be minus 2, or you could say plus a negative 2 times x minus 2. Then you want to simplify. 2 times 3 is 6, and then you have negative 2 distributed, which would be negative 2x plus 4. Combine like terms, you combine the 6 and the 4, so that would be 10. Now I'm going to subtract 10 from both sides. I get negative 7 equals negative 2x. I'm solving for x, so I want to divide both sides by negative 2. That's negative 7 divided by negative 2, and the negatives cancel out, leaving you with just 7 over 2. Then you want to check. If you look at the denominators, you know that the denominator cannot be equal to 2. This is not 2, so you don't have to worry about the denominator being equal to 0. That's what you're checking for as a restriction. And that's it. So when it comes to the operations with rational expressions, you want to think fractions. You also need a factor. So simplifying rational expressions and multiplying and dividing rational expressions, we went over that last unit. But the steps are very similar to fractions. So you know you have to factor, and then once it's factored, you can cancel things out. With adding and subtracting rational expressions, it's just like adding and subtracting rational numbers. So you do have to find the LCD. Once you find the LCD, you use equivalent fractions to get the denominators the same, and then you would add the numerators referring to the top part of the fraction. So you would add the numerators, and then you would simplify if possible. With rational equations, what you can do first is multiply by the LCD. You multiply by the LCD, and all the denominators cancel out. At that point, either you have a linear problem where you're just solving for x, or you have a trinomial or something larger to where you have to solve by factoring. And that's it. Thank you for watching this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below.